Hello guys, welcome to GG Physics by VG sir. So today I'm going to discuss one very important concept from electrostatics. So first I'll give one example, and after understanding that concept, then I'll take up a question from the Pathfinder, and then let us see how it goes. Okay. So the concept that I'm going to take today is finding force on a uniformly charged surface. Okay, finding force on a uniformly charged surface. So the problem here is, see, when we have 2 point charges, by using Coulomb's law we know the force between 2 point charges, right? So Coulomb's law is valid only for like what, 2 point charges, that is kq1 q2 by r square. So that's the magnitude, right? But here the problem is, so we are going to find the force that is acting on a continuous object, so that is like a uniformly charged sphere. Okay, so first let me explain the concept. Okay, so let me take a point charge q over here. Okay, so let us consider point charge q over here, and we needed to find the force that is acting on a sheet. Okay, this is a sheet, let's say, which is symmetrical. The sheet is placed symmetrical. Symmetrical to what? Symmetrical to the point charge whatever that is there. So actually it's a 3D figure. Okay, you guys try to imagine. So then better let me draw this way, then it will be nice. So let's say consider is a sheet like this. Okay, so which is like symmetrical about this point charge q. Now let's say this has a surface charge density of sigma. Sigma is the surface charge density for this one. So now we need to find what is the force between this point charge and this surface whatever that is present over here. So I guess by now it's pretty much clear that you guys can understand that we cannot use Coulomb's law here directly, because one is a point charge and the other one is not a point charge, right? So this is the problem over here. So obviously, so when we get a new thing, we should always go and stick to our basics, right? So from our basics only, let us try to tackle this thing. So now what I'm going to do is, so as this charge is symmetrically placed from this sheet, I'm going to take a small patch over here. Okay, small patch over here, small patch. This patch area, let me take it as dA bar. Okay, which is normal to this surface area whatever that is there. And due to this q, this is dA bar. Okay, dA bar vector direction is this one. Let me take this dA bar over here. Okay, so this dA bar, 1 second. So this is the dA bar area vector, and we know that due to this point charge there will be electric field, let's say E bar in this direction. Okay, which is radially away, considering that this is a positive charge. Okay, now you guys need to understand, as I said, this is a symmetrical shape. So there will be a counterpart over here, for which there will be electric field over here also, right? So due to symmetry you need to understand that whatever the force that will, so for sure you can understand that force on this part. Okay, it will be there in two different directions that you need to understand, because you will get a component of electric field along horizontal direction. Let me consider this angle over here to be theta. So obviously you need to understand that along horizontal direction you will be getting e cos theta component, and along vertical direction, that is along the surface, you will be getting e sin theta component. But here the most important thing is this e sin theta component whatever that is present over here. Okay, the force due to this e sin theta component will be cancelled due to this counterpart whichever that is present over here, right? So if you want to find the net force due to this point charge on the surface, it is more than enough just to calculate whatever the force that is perpendicular to the surface, right? So let me write the df magnitude wise, okay, which is perpendicular to the surface. So that can be written as charge multiplied by charge. What will be the charge? Sigma into dA. multiplied by the electric field whatever that is present over there, right? So what is the electric field that is present over there? E cos theta. So you need to understand here that this theta will be keep on varying by taking different dA elements over here. And also you need to understand this E bar is also going to change. Okay, when we are going to go for the different points, the distance also is going to change over here, and also the angle between the dA bar and the E bar is also going to change. So theta is variable, E is variable, and sigma is constant. By the way, sigma is constant because it's a uniformly charged sphere, right? Now, except this sigma, this E and theta both are variables, and moreover we need to integrate these two over what? Area, right? So it's you need to understand it's not a direct solvable integration that we are having here. So anyway, let me find, so the total f net, I can get f net by integrating this, right? So integral df, so which is nothing but, you need to understand that I can take sigma outside because it's a constant. So let me take the sigma part outside. Then what is left over here? So that the remaining part that is left over here is, I am just trying to rearrange this in this manner, E into dA into cos theta. So by looking at this whatever this term that is over here, you need to understand that this is nothing but, okay, this can be written as E bar dot dA bar, right? So that can be written as what? So that f net can be simply written as sigma times integration of E bar dot dA bar, right? So this can be simply written as what? E bar dot dA bar. And you guys know that this integral E bar dot dA bar is nothing but what? So this integral E bar dot dA bar is nothing but our flux. That means it's nothing but the flux due to this point charge, okay, through this surface, right? So therefore, the net force I can simply write, it's nothing but the surface charge multiplied by the flux. Okay, so this will be our force magnitude. You need to understand, as it is symmetrically, this charge surface is kept symmetrical. Okay, this vertical forces will get cancelled, only the force will be perpendicular to the surface, right? Here the most important thing is, you need to understand what is this flux. This is flux due to the point charge through that through the surface on which force the force is to be formed, on which the force has to be calculated, so this is the formula that we have derived. Okay, so you can understand, you can consider this as a very good concept which will be helpful in solving very good problems that are based on electrostatics. So what is the final result that we have derived? So the net force, okay, due to this point charge on the surface is nothing but sigma multiplied by the flux due to the other charge. What is the other charge that is present over here? The other charge that is present over here is this point charge q. So you just need to find what is the flux due to the other charge through this surface on which the force to be formed. And we just need to multiply that flux with the surface charge density of this whatever the body on which we need to find the force, right? So I hope the concept is pretty much clear for you guys. So now I'm going to take up one very nice question that is given in Pathfinder. Okay, so the question goes like this. So basically they have given a cube which is uniformly charged. Okay, so they have given a cube which is uniformly charged, and they asked us to find so the entire cube, so they have given that the entire cube has a surface charge density of sigma. Now the question is, we need to find what is the force on one of its faces due to the remaining body of that like cube. Okay, so here we know one more important thing. okay, in the basics, that a charged particle cannot apply any force on itself, right? It can apply any other charge that is present in its vicinity, but it can never apply any force. It cannot apply force on itself, right? So let's say I am considering this phase over here. Okay, so let me consider this phase. What is the phase that I am taking? Let's consider this, let's say A, B, C, D. So I'm considering this phase A, B, C, D. And let us consider that, let's say the side length to be L. Surface charge density is sigma and side length is L. Now we need to find the force on any phase, right? So I'm taking this ABCD phase over here. Okay, I'm considering this phase. So now, in order to find force on this one, based on this concept, we just need to find, as we know already know the surface charge density of that like the body on which we need to find the force. We just need to find the flux due to the remaining charges. Okay, we just need to find the flux due to the remaining charges, whatever all the remaining charges that are present through this surface ABCD. Okay, for this to understand, so we know that, first let me write the total charge. Total, 1 second, yeah. So total charge is nothing but sigma times, okay, it's surface charge density. So we have six surfaces, right? So we have six surfaces, so it will be 6L square. Sigma into 6L square is the total charge, right? And total flux through the cube. Total flux through the cube. Total flux to the cube. So you know, if I consider a Gaussian surface just, okay, just covering this the cube, I'm considering a Gaussian surface which is in the shape of cube itself, okay, which is just covering this one. So the charge present inside that Gaussian surface will be this one. So we know the flux. Okay, according to the Gauss law, the flux will be written as Q enclosed by epsilon naught, right? So it will be simply 6 epsilon naught L square, 6 epsilon naught L square by, this is Q in by epsilon naught. Okay, but here the most important is, this is the flux that is going through the entire, this is the flux that is going through this entire cube, right? So let me find the flux through each phase. Okay, flux through each phase, right? Flux through each phase, as it is the entire figure is symmetrical, so flux through each phase will be this divided by 6. So that means it will be simply sigma L square by epsilon naught is the flux through each phase. But here one more important thing is, for using this formula we need to find flux due to the remaining charges, right? But here you need to understand that in this sigma L square by epsilon naught, there is a hidden flux. Because of what? Because of this phase. As we can clearly see that this phase is also having a charge. Okay. So because of this charge also, there will be a flux that will be produced beside that. So whatever the flux that we are getting here, that is sigma L square by epsilon naught, you need to understand this is because of the entire cube. But to use that formula and find force, we need to write the flux due to the remaining thing on this ABCD phase, right? So that means I need to remove the flux due to this ABCD phase, flux due to this ABCD phase, okay, from this one, right? So that means now I am writing flux due to flux due to ABCD phase itself. So that, how to find this one? This is a question mark, right? How to find this one? It is also very simple. When I consider this phase, whatever that is there, okay, let me consider this ABCD phase that is over here. So it's a sheet, and this is carrying a charge of what? Sigma L square. And you know that it will carry a total flux of what? Total flux of sigma L square by epsilon naught. And you need to understand that half flux will be going through this side. Okay, half flux will be going through the left side. That means, so in this one, Okay, in this sigma L square, the flux due to ABCD phase, flux due to ABCD phase will be equivalent to what? Will be equal to, that is also equal to sigma L square by epsilon naught only. But you need to understand, so right side half will be there, left side half will be there. That means, and this whatever this flux that is there, the total flux, okay, that is passing through this ABCD phase, that is due to the entire cube. So in that we need to remove the flux due to what? The ABCD phase itself. So therefore, the most important thing is this one: the flux due to remaining remaining all the phases through the ABCD phase, ABCD phase is equal to sigma, this pink one that I'm going to write is the entire flux, that is sigma L square by epsilon naught. And this pink, with the green one, I'm removing the self one. What is the self one? Sigma L square by 2 epsilon naught. So that means what is the flux that you are getting due to the remaining all other charges? The flux that I'm getting, the net flux that I'm getting, is nothing but sigma L square by 2 epsilon naught. This is the flux due to all the remaining charges. Okay, this is the flux due to all the remaining charges on the ABCD phase. So therefore, the answer is done, final answer. So therefore, force on ABCD phase is given as, from the above formula, it's nothing but what? It can be simply given as what? Force due to this all the remaining charges on this phase. Let me move it a little up. Ah, force can be given as what? The formula sigma times the flux. What is the flux that we got? Sigma L square by 2 epsilon naught, right? So we got the final answer. So what is the final answer that we have got? So therefore, the force, the answer is what? This will be the answer. Sigma square L square by 2 epsilon naught is the force that will be acting on the phase ABCD due to the what? Due to the remaining phases, right? So I hope you understood this concept. This is one very important concept in electrostatics, which will be which will be helpful in solving very important questions, either from Pathfinder or IRIDO or different AITs, right? So this is a very good concept. Okay, you guys can just go through this again and practice some questions, okay, that are given in IRIDO or Pathfinder, or that you can find in AITs. Okay, so I hope you guys like this video. Okay, so if you like this video, please comment. So comment for whatever the concepts that you want me to teach in upcoming videos. And also please don't forget to like this video. So it will be very nice and encouraging for me to do more and more videos like this. Okay, it's just an encouraging thing that you can it's a minimal thing that I'm expecting from you guys, so that it will be just like boosting for me to keep more and more efforts from my busy schedule. Okay, even though I like my schedule is like very busy, so I need to guide some offline batch or here, right? So to take some time and deliver this type of content, I just want some motivation. So that's nothing but just like and comment. So I hope you guys liked and enjoy this lecture, whatever that is I have presented. Thank you guys. Keep enjoying. Bye bye.